The coupling of modern neuroscience and technology provides increasingly effective tools for measuring, deciphering, and manipulating the patterns of brain activity that govern our perceptions, emotions, decisions, and actions. While neurotechnologies emerging from these advances show promise in treating a range of disorders, they also raise legal and ethical challenges concerning user privacy and individual agency. And so to address these challenges, this panel brings together experts from bioethics, law, and clinical neuroscience. So unfortunately, one of our panelists, Francis Shen, wasn't able to make it, but we're thrilled to have our two esteemed panelists that were able to be here. So Winston Chung is an associate professor in the UCSF Department of Neurology, principal investigator of the UCSF Decision Lab, and interim director of UCSF Bioethics. His clinical practice focuses on Alzheimer's disease, frontotemporal dementia, and other cognitive disorders of aging. Dr. Chung is also a member of the UCSF Department of Neurology Diversity Committee and the UCSF Medical Center Ethics Committee. Nationally, he serves on the NIH Brain Neuroethics Working Group and the American Academy of Neurology's Ethics, Law, and Humanities Committee. He received his PhD in philosophy from NYU and MD degree from UCSF. Sarah Goering is professor of philosophy at the University of Washington, Seattle, where she co-leads the Neuroethics group at the UW Center for Neurotechnology and has affiliations with the UW Program on Ethics and the Disabilities Studies Program. She's co-PI with Erin Klein for an NIH R01 on brain-computer interfaces and human agency. Her work includes normative philosophical argumentation as well as empirical work focused on understanding the lived experience of users of neural devices. Please join me in welcoming our two panelists. So as with the previous panels, the structure will be, we'll spend 45 minutes doing a discussion up here, and then the last 20 minutes we'll have audience Q&A. And I encourage you to continue this conversation on Slack with the Slack channel posted up there on the slide. So Winston, if I can ask you first as the MD clinician on our panel, what are the key brain interfacing technologies, whether that is a device that reads out brain activity or stimulates the brain? Walk us through the basic mechanics here. What are these devices doing, and what current clinical uses do they have?
Sure. I was trying to think about this question, and it might be useful to think about it in sort of a grid, like maybe like a sort of a 2x3 grid in terms of techniques we have for reading brain activity, and then techniques we have for stimulating brain activity. So that would be like one dimension. And then the other, I was thinking in time scale. So there are certain ones that are used intraoperatively, and you know, these are all really right now being done in the context of people with indications for different kinds of neurosurgical procedures. We can talk later about potential extensions in other domains. But there's a long history of both recording from the brain and stimulating the brain in the context of a neurosurgical procedure, right? So think about people like Penfield in the 50s. So if we think about our homunculus map that we have of the brain, that's a good example of really kind of basic neuroscience that was being done in a clinical setting when it was necessary to map out what parts of the brain were necessary for different functions to avoid resecting them in the context of a tumor surgery or an epilepsy surgery or something like that. And so that's an example of a stimulation technique that was used to map out the brain by applying current to different parts of the brain and mapping out what brain functions were associated with what regions. And we also developed techniques at the time to record brain activity, again, in the context of a surgery that would guide the care that somebody was receiving. And then outside the operating room, there are certain indications for sort of temporary stimulation or recording from the brain. So this can be from really, I would say, timescale of about a week to several months right now, depending on what kinds of sort of temporary devices are used. So common scenario here would be that a patient might have epilepsy, and we might not know exactly where in the brain their seizures arise from. And so in many cases, we will, or not we, I'm not a neurosurgeon, but a neurosurgeon will implant electrodes in their brain, and then they'll stay in the hospital for about a week, and then continuous recordings will be done, and the patient's usually taken off of their anti-seizure medications, and actually the hope is that they'll have one or two or maybe more of their typical seizures while in the hospital with these temporary electrodes implanted. And then that can be something that can be used to guide their care so that we know where their seizures are coming from, things like that. And then this has gone out to sort of temporary but outpatient settings. So some of the brain-computer interfaces and other things that are being developed are with devices that still require some external wiring. And so oftentimes there will be an implant that has a sort of pedestal to which an output can be attached that will connect it to a computer for different reasons, usually for research purposes. But that's not something that usually people can keep permanently because there is a chronic infection risk often associated with the pedestal for this. And then finally, there are more or less potentially permanently implanted devices that are used for clinical purposes. The kind of classic example here of a stimulating device would be a deep brain stimulator for Parkinson's disease or another movement disorder. And typically that's a device that, again, in most indications, delivers a more or less continuous frequency and intensity of stimulation to a target region of the brain. And that can be sort of titrated to a patient's clinical symptoms. And that's a device that a patient can keep in their head forever. We don't have great examples of chronic sensing devices in the brain. There were some experimental seizure prediction devices that were developed, but not fully come to market. And then kind of bringing those together would be chronic devices that can both record and stimulate the brain. And this would be sort of closed loop neuromodulation, where recordings from the brain are used to guide stimulation that's delivered. And one example of that our sociologist in our group, Toby Hauserman, who's here, has done a lot of research with is responsive neurostimulation for epilepsy, where the device detects electrical activity indicating that the patient's having a seizure and then delivers electrical counterstimulation to interrupt that seizure and reduce the severity of a patient's seizures.
Great, thank you for that framework. Oh,
Can I
yeah,
add something?
of
Even
course,
though
yeah.
I'm not a physician, just to kind of give a picture of some of the things here. I think in my own work doing this grant, looking at human agency using neural devices, I would say also there are people who use it really to see what's possible in a way. So I've worked with people who have spinal cord injury who have one of these pedestals implanted, right? It's wired, so they need to go into the lab to use the device. And they learn to control a robotic arm or a cursor on a screen through mental imagery, basically. And it takes a lot of training to be able to control it, but then they're able to control it. Those people have some fun doing it. It's kind of like a job for them. It might be there for 3 to 5 years, right? As they're going in, if it's not a global pandemic, 3 times a week to do a study. But it's not therapeutic, even if it's experimental in any way. It's just there's a paper out doing things with thoughts. It's a cool way to see how a person can interact with the world when they aren't moving their own musculature. They're just using visual imagery. But that's very different from some of the studies where it's experimental, but somebody really, if it's working for them, they're really benefiting on a day-to-day basis from having it. So some of the people we've talked to have a deep brain stimulator in an experimental study for depression or OCD, but it's traveling with them 24/7, right? It's on all the time. If it's working well, it can be a lifeline for them. And I just think those two kinds of things are very different in terms of what's at stake for those people if something happens to that device. Because for some people, it's a really interesting thing to do, but that's it. And for others, it really, the only people who can get in this study have treatment-resistant depression. So it's been something they've struggled with for a long time, and it can really be a lifesaver for those people.
I'll just follow up a little. We may never get to that second question, by the way. Sorry. But I think that this issue of right now we're still kind of in the biomedical and research space. We may hopefully get to the commercial space also, but in the biomedical and research space, this question about what people's motivations are for engaging with research or engaging with care in this way will of course be relevant when we talk about privacy, because we're talking about sort of the trade-offs and also among other things, what space people have to say no, right? If they don't agree to the terms of whatever is involved either in enrolling in a research study or not, and so that's also relevant to how much power people have in the relationship with clinicians or investigators, what kind of bargaining power they might have with commercial entities as well. So there is a range here of research that's done and people can participate in more or less altruistically, although also there are personal motivations that can enter into research in terms of something being interesting or engaging or fulfilling. And it's very different when people are engaging even in a research study for at least a hoped for therapeutic purpose, right? Where it might be an experimental treatment for a condition they have where they don't really have other options. And then of course, there's also, in the case of DBS or in the case of RNS for epilepsy, those are just approved standard treatments, right? That's just that your doctor says this is what this is the best treatment for you, and people engage with the device on that basis, where that might not be an experiment at all, and people they're just trying to get better, right? They don't have any scientific or other intent involved.
Yeah. So let's take the specific example of this clinical use and a chronically implanted medical device, whether it's doing closed loop or DBS. So the concept of a chronically implanted medical device in our bodies is not something new. I mean, we've had cardiac pacemakers around for some time. So Sarah, perhaps starting with you, just to help us ground this discussion about privacy and individual agency. Why is technology that interfaces with the brain in particular, why does that put us in an ethically unique and perhaps uncharted territory? So what is so intimate about brain activity?
Yeah, I mean, I think it's not a surprise to anybody. If we have a cardiac pacemaker, it can be necessary to preserve our lives. Hearts are very important, but our hearts are not central to our sense of ourselves as agents. We think of our brains. I don't think we are our brains, because my body matters a lot, and it allows me to negotiate with other people in the world and do enact the things that I want to do. But my brain is kind of the central processing part of me, and it includes not only the things that I am consciously aware of and planning and experiencing, feeling, thinking, but also lots of subconscious things that are huge influences on how I behave and interact with the world and how other people see me. And so when we think about having a device in that part of us that can influence or modulate the activity of our brains, of course, we're aiming to do that influencing or modulating for the benefit of the individual. But as we think about further extensions of these kinds of devices, I think there's also this worry that there may be ways that my brain can be modulated without me fully being aware, right? And so, we have experience even with therapeutically approved devices like DBS for Parkinson's disease, where some people will have benefit in terms of reduction of tremor, but they'll experience increased impulsivity, which can be very difficult if family members are worried about their gambling behaviors or just their interactions with other family members. And it's fascinating when you look at some of the empirical literature on this. Sometimes the individual herself won't recognize that change in herself, but all the family members will come to the study leaders or the physician and say, this, she's really changing and it's very difficult to be around her and we need to intervene in some way. So I think because it's so central to how we understand ourselves and also how other people understand it, that there's just this heightened sensitivity to having some kind of long-term recording device that is capable of stimulating. Do you want to say more?
I mean, you sort of set us up with an easy question, right? Because I think everyone, at least who's sitting in this session, maybe the people in the other session, they might not see it, but the people who are in this session, what other point I would just make is, when we look at popular culture and popular art, I mean, there's so much great art that has been made, in terms of movies, in terms of TV shows, things like that, where this is something that occasions a lot of excitement, a lot of fear. People can see a little bit some of the trends in this direction. Obviously, we have a much more intimate relationship with mobile computing devices than we did a decade or so ago, and those have been transformative, in many beneficial ways and in many harmful ways to our lives and the way we interact with one another. And so it's not difficult to imagine how further advances in technology in this domain could have wide-ranging effects on how we communicate with each other, how we think about ourselves, things like that.
So I want to dig a little deeper into what some of those concerns are, because both of you in your research kind of go out in the field, so to speak, and really chronicle the experiences of the users of these medical devices. And so, Winston, perhaps we can start with you. What are the main concerns ethically and perhaps also legally? I mean, we don't have Francis's perspective, but if you're comfortable talking about that at all, when we look at the challenges that are faced currently by users of, say, closed-loop neuromodulation devices.
I think there are probably ones that are common across a lot of brain devices, and then there are other ones that might be specific to different indications. And so I think we do have to be very careful when we extrapolate from studies, that Sarah and her group have done, or that Toby and our group and other people in our group have done, and try to think about what might be common across brain devices, and then what might be specific to a particular indication. So we recently did a study, a very in-depth study on, again, patients with the RNS device for epilepsy. And it was quite fascinating in some ways because some of the things that we were anticipating or had been thinking we might see didn't come up as much. And then there were other things that we had not anticipated that were very, very prominent. And so at least in the case of epilepsy, we didn't see a lot in terms of the device being perceived as shifting people's sense of agency or personality or identity. Should be said that we're really focused on people in the first year of having the device. And so it's possible that just in that first year, the device is being tuned. There's a lot of focus on just the clinical phenomena in terms of trying to get the patient's seizures better. And so, we're hoping to follow some of these patients more over time and get more of a sense of, some of those concerns might come to the fore if patient seizures are better controlled. But one thing that we had not anticipated to the same degree was actually the extent to which the recording from the device was really significant and meaningful to people in terms of how they thought about the illness and kind of how, like, what expectations they formed for their care from clinicians. And, to some extent, the device became a kind of agent itself just from the testimony of the device. So, in many cases, without a device, a patient comes to the clinic and they bring a record of their seizures or other phenomena they think might be seizure activity. And then their neurologist will be sort of a conversational partner in terms of trying to interpret these events and try to think about, based upon the neurologist's understanding of the anatomy and their understanding of the patient, how to interpret these events. And that's a big part of the clinical encounter between the patient and the neurologist. Well, when you have a device that is always sensing the patient's brain activity and can record these events, then that device itself sort of enters into the conversation, right? And sometimes the device can confirm what the patient thinks about what's going on. In other cases, the device can contradict the patient. And then that raises certain kinds of challenges. First, in terms of knowing whether or not, like, just because a device is a computer doesn't mean that it's always the reliable one, right? Like, we should avoid and there's all kinds of reasons why an event that actually was a seizure might not have been detected by a device, given whatever rules or algorithms were given to the device for what to store and record, or just given the placement of where the electrodes are and maybe potentially missing where a different seizure is arising from. But these experiences can be very decentering for patients in terms of really that to some extent if not their experience, then at least their interpretation of their own experience can be questioned by having a device that is kind of regarded as being sort of extra reliable in this way because it's because it's a computer, because it's continuously recording, and also just because there are many reasons why people with epilepsy may doubt themselves and may doubt their own memory. So there's a very interesting dynamic that we saw sort of develop between patients, their caregivers, the device, and their clinicians.
And Sarah, in your research, you've focused not only on the users of these devices, but you mentioned earlier their relationships with their close family as well. So I wanted to ask you, what do these relationships reveal about the impact of these devices on something like the user's individual agency?
Yeah, so we went in to do this study talking with people who have DBS for depression and or OCD, and did not, again, right, you go in with certain ideas and things in your interview guide, and then other things come out. And one of the things that really popped up for us that we hadn't expected were sort of what we call relational effects. So people would say they have the device. Some people have a little patient controller where within a certain set parameter, they can turn it up or down depending on the circumstance they're in. And they would say, one person in particular stood out to me who said she would get in an argument with her father, who wasn't particularly good to her historically, and be in tears. And he would more or less say, like, let's turn you up. That not taking accountability for the fact that he did something to her that put her in this state of mind, but thinking, well, the problem is in you. And we have this little device that we could try to make you feel better, because people would report that when it was turned up, they felt better fairly immediately, unlike, say, taking an antidepressant or something that takes longer for the body to metabolize. And as she said that, this was a focus group, there were people around the table who said, oh my gosh, yes, it's always, is it the device? And their language was, it's so dehumanizing. It treats me as somebody who is dialable, right? Rather than somebody whose reason's responsive or has an emotional life. And so that kind of issue came up. Another person in that group said something when we were just posing it as the prospect of a closed loop device. If we try to find some biomarker to set a closed loop DBS for depression to, would it maintain a certain kind of mood or a certain, higher, lower level of mood than was responsive to the world? So we had the scenario of somebody going to a funeral where it's appropriate to feel sad in that kind of condition. And, we thought we were posing a hypothetical, and a woman in the group said, but that happened to me. I had just with a one-way stimulator, she said, I had it adjusted, the settings adjusted, and I felt pretty good. And then somebody died close to her and her family. And she went to the funeral and just couldn't feel the thing that she expected herself to feel or felt that she needed to feel and show to demonstrate the relationship that she had with the deceased. And so, right, it kind of points out the need to have something that can treat the so far treatment resistant condition, and yet also to have something that allows you to be appropriately responsive to the very changing environment that you find yourself in. Then the other side of that, I think, is that we're really interested in agency in our group. And part of that is understanding our feelings of being responsible for action or for things that we do. And we had people both in that group and then in some of the BCI studies we've done who would say, I found myself reacting to somebody and it felt out of character for me. And then I thought, is it me? Is it the stimulator? Is it the fact that I'm living with depression? I can't quite pinpoint. We're not transparent to ourselves in our own heads. We often need other people to help us figure ourselves out. So the sense of agency for that behavior, I think, was very fuzzy for him. And that similarly, right, thinking across different kinds of devices, in this paper I mentioned before, Doing Things with Thoughts, not from our group, a different group, they say people who have trained to use the robotic arm or trained to use the BCI device to control a cursor will sometimes think, am I not focusing enough? Am I really tired? Or am I not controlling it because the neuron that they had it tuned to is quiet and then they have to retune it I don't know if it's there, if it's me, or what's happening. If we ask them if it fails, what do you think? They would often think it must be the device. But, but what part of it, or how do you know when to take responsibility for the thing that follows from that? So I think this doesn't mean that we shouldn't keep exploring these devices, but it means we have to pay attention to how they intervene on a person's sense of agency and having responsibility for the things they do, whether that's feelings or actions, I think.
Yep, go
We're
ahead.
just going to keep taking
Yeah.
it, hopefully. So I think that these stories are also revealing about kind of how we think about our brains and how we think about brain conditions. And one of the reasons I said before that lessons from one set of patients or one set of users may not generalize is that there's so much interpretation that already goes into having a brain condition where you might need a device, right? At least in these clinical contexts. And so I think that one of the things that we heard routinely, and this is not very surprising, uh, epilepsy is a condition where people feel a tremendous loss of agency, and that is one of the things that people fear most, right? Is losing control, not and kind of not even being there and having no recollection, and it's one of the things that's quite horrible for people is to get reports later on of something that had happened or something they had done. And so that there is like a really remarkable kind of dissociation that people experience in many cases, to their own brain, to their own experience. And I think that I don't know if it's exactly a spectrum, it's some kind of complicated space, but when we think about things like depression, when we think about things like eating disorders, when we think about things like Parkinson's disease, I think that those already reveal, even absent a device, just the many kind of complicated ways that we can understand ourselves and we can understand our brains, and the ways in which how we think about our brains informs this sort of self-interpretation that we're always giving when we're going through the world. And I mean, I think a lot of us spend a lot of time trying to figure out why we did certain things or said certain things, and and of course, having a brain illness can be a big part of those interpretations. And then having a device that's intended to treat a brain illness layers on another kind of set of complexities. And so I think that there is something that is quite individual to each person in terms of how they negotiate this understanding. But of course, it's informed by a lot of these shared experiences, within these different conditions, and some of it is neurobiology as well.
Can I just add too? I think because there are so many different devices, right? In some of the interviews we've done, most of them are just for the BCI side are really control with a robotic arm or control of the cursor, but some of them add sensory feedback so that if you have the robotic arm and there are sensors on the fingers of that robotic arm, then you're getting sensory stimulation, right? Which would make it easier to embody and easier to treat as your own limb if we look to the future. But then in doing the studies, which are sometimes in epilepsy monitoring units for stimulation, right? People are getting then strange sensations without having strange sensory sensations without having any visual of that happening to their arm or their foot or whatever it happens to be. And I think when we look ahead to, if you have a device that works well, then this is the experience I'm getting. If the device can fail in ways, right, that we aren't aware that it's failing and give me a different sensory perception, like this is our world. This is how we perceive things. We don't, all we ever get is through our senses. So then when we can go direct to the brain to give us some kind of sensory impression, Humean sensory impression of the world, there's such a worry there, I think, about confidence in the experience representing the way things actually are, or just opening up a possibility for shifting what we believe we're experiencing in the world.
Yeah, that's great. Thanks for that. So I'd like to switch gears now, and I think this is something of interest to a lot of people when we think about neuroethics. I'd like to talk about the future trajectory of these neurotechnologies, these devices, particularly if they stray outside of the sort of niche clinical applications we've been talking about. So, for example, we see a lot of interest and investment in something like brain-computer interfaces from private tech companies. And we've all probably seen sinister sounding headlines about, mind reading and, cognitive enhancement that would benefit the wealthy with access to it. So a question to each of you is really, in a realistic sense, what do you see as the biggest ethical and also legal challenges if neurotech becomes more widely accessible and adopted throughout society? And I guess specifically, I want to bring a historical lens to this where we are at this moment in time is not unique. We have a technology and it'll likely be used by people with access to the resources. And so it'll bring about familiar issues of enhancement and racism and socioeconomics. And so when we're thinking about the development of these devices, what are some ways in which we can kind of mitigate these challenges? So Sarah, I guess we'll start with you.
Those are lots of questions. What's the biggest issue and how do we mitigate it? Let's start with, I think a huge issue when we go into the consumer space is going to be privacy. We were just saying before the panel, I've been to other sessions here today and yesterday where we talk about all the infringements on privacy or the loss of privacy through social media and shopping, purchasing, everything around us, facial recognition software, et cetera. And I think given the actors who are most interested in getting apps and developing BCI for consumer purposes, I just think there are lots of ways in which our brain data or our neural data will then be used similarly to all of our social media data and everything else in ways that we don't fully understand and get aggregated with that, so that things that I think are very preciously private now, if not right now, may one day be interpretable, not mind reading. I know exactly what's going on in there right now, but interpretable enough that things that I prefer to keep private and not express might be externalizable by, device makers who convince me that for the purpose of playing my game or making my grocery list without writing something down or whatever, right, that it's going to be of benefit to me. And I think we're not making good decisions about that now. And this is a kind of last bastion of privacy that I think we should really put some fences up around to make sure that we don't end up with our brains in the same position that, all of our purchasing interests are made into data that's sellable and usable by actors where we don't know how they're using it.
I find it a little hard to to go that far in the future. Just it depends a little bit on different ways things could play out, and it might be useful to entertain different ideas about what this looks like, right? So there's clearly a lot of interest in this sort of space. It's not so clear to me yet what the use case will be like for commercial use. I think that, for instance, in the case of neural enhancement, so far, we haven't gotten very far in terms of, and a lot of things that have been thought to be neural enhancers have been shown not really to be. So, to some extent, we, maybe things are going to depend a little bit on what we learn about, for instance, how well optimized the human brain is for solving the problems that we face. And I think also a big difference will be whether or not we're able to do these things with extracranial or sort of non-invasive applications, just because I think that, despite the thoughts of some technologists, I think that most people will not be willing to get neurosurgery for a consumer device. And there is also a problem we actually see in the medical space as well, which is sort of a early adopter problem, right? Which is basically if you get implanted with a device and a later device comes along, this is something that's implanted in your head. It's a little different than upgrading your phone. So, I think that there are going to be certain barriers to the adoption of implantable devices. I mean, it may come in the future, but I think that's a lot further away, both for, there are just a lot of the technical challenges, but I think there are also just going to be sort of marketing and, kind of challenges about the kinds of personal decisions people make. I think that if what we learn, say in these clinical contexts, with these very specialized intracranial devices, leads to discoveries that can be applied, with extracranial technologies, right? So if there's different kinds of, brain recording through EEG or other kind of extracranial methods, and similarly stimulation that's done, through something like, TMS or TDCS, then I think that would change a lot, in terms of the scope and breadth of those technologies, and that would also speak to some of the worries that Sarah has, right? So I think that if you have a device that's implanted, then it requires consent to get it. Well, I was just watching the show Made for Love. That's that's an example of somebody. But so some of the privacy considerations are a little bit lesser in terms of kind of who has access to that device and what's required. Obviously, there's all kinds of privacy considerations that might come into play if it's possible to do some of these things extracranially. One other difference between some of the huge advances we've seen in mobile computing and what we might envision, at least in the early era of consumer neurotechnology, whenever it is. The early era of consumer neurotechnology could be like 50 years from now. I don't know. But I mean, it is a difference between wide and long data, right? So a lot of the power of companies like Google and Facebook is that they have millions or billions of people that they can use, and then that allows different kinds of machine learning to make predictions on people that are really probabilistic, and it doesn't actually matter, like slight shifts in improving the probability of some prediction when applied over such a large population can have like tremendous financial benefits, right? So just even incremental, like, a 0.5% improvement in their ability to predict whether you'll make some purchase, if you're one of like 3 billion people in a user base, those are things that can drive kind of a lot of innovation. And the data sets are very, very wide. And so in some ways, it's very easy to build new models and make new predictions. I think that right now in the neurotechnology space for the clinical space, these are actually underutilized technologies. That's one thing that should be said. So there's a lot more people who would benefit from DBS for Parkinson's disease than who get it, related to many of the access issues that you mentioned. RNS for epilepsy, it's almost even silly to talk about because there's even more basic treatments for epilepsy that are not given commonly enough. So sometimes, like when we talk about access to this neurotechnology, there's like 15 steps along the way that we like would have to address just in terms of like even more basic treatments that people don't have access to, partly because the very close association between neurological illness and socioeconomic disadvantage. So the median income of the median household income for a person with epilepsy in this country, I think, is below the poverty level. So most of the people that we're talking about, because the illness is so disabling and because the risk of the illness is largely correlated with socioeconomic disadvantage, there are just tremendous access issues before we even talk about putting something in someone's head. But anyway, so there's like a relatively small group of people that have these devices. So, but then we potentially have a lot of data on them, right? So that's why I said that's a long data set as opposed to a wide data set, which raises different kinds of challenges. One is that the re-identifiability of any one person's data is higher because we're talking about a smaller pool of people. But the kinds of techniques that have been leveraged with mobile computing data, for instance, those aren't going to apply in quite the same way just because you're dealing with a smaller N. And so kind of your ability to generate more models for prediction, again, you're going to have lots more events for each kind of individual person in the data set for making predictions, but you won't be able to leverage, at least at this point, kind of the billions of people that, like a Facebook or Google, the advances we've seen in AI and mobile computing have been based on.
So I want to dig a little deeper into something you've alluded to, which is that perhaps we're just performing anticipatory ethics because the neuroscience actually isn't there yet. We certainly can't decode people's thoughts, and it's not clear whether we ever will be able to in the ways that people imagine. And so my question is that if these imagined futures never really arise and we're just performing anticipatory ethics here, is that necessarily bad? Like, what explicitly are the dangers in doing that? And should we be acting now?
I think so. I mean, I think I've been in other panels here where we think we're too late. We're always too late. It doesn't mean that we need rock solid, never changing banning of things, right? But I think we want to protect things that are worth protecting and then see what follows, right, as we continue to develop the technologies. So I've been in a variety of symposia and other workshops with Rafa Yusta, who's been working really hard on trying to get people to talk about neuro rights. He uses that language. I don't really care if we use that language or if we just talk about making sure that our rights to mental privacy and mental integrity are protected and recognized. I think if we have enough rights within the UN Declaration or within our own Constitution in the US to cover those things, then we should use those and interpret, but we need to pay attention to it so that we don't wind up giving away all this data or giving away what is a very important aspect of ourselves. our mental privacy as things develop. And I think for me as a philosopher, I have been moved by neuroscientists who are working with animal models and sometimes with humans who say, yeah, we're not there, as Winston said, especially for consumer devices, who knows how soon, but now is the time to act, or at least think about how we're going to act so that we can sort of slowly steer the ship in a direction that we want it to go and maintain the things that we really value.
I think it's important to articulate principles. I think, and particularly when there are people who are signing up for things now, like I think a good example would be, well, what might be recoverable, let's say from neural data, right? So there are people who are signing up for studies now, and we have increasing interest in data sharing. We have increasing interest in the availability. We should be thinking a little bit ahead in terms of, we've run into this issue in genomics in terms of, whether or not genomic data is re-identifiable. And, we should think a little bit about, particularly if, somebody's been implanted in a particular place in the brain, that itself might be a certain kind of signature for, having electrodes in a particular place. And then, of course, it's very unlikely that we will be able to decode rich neural contents often from the very sparse recordings that are done in most research settings right now. But I think leaving open the possibility that there are broader network states or things like that that could be recoverable. Thinking about that in the future, somebody who's signing up for something now, we should try to think a little bit ahead about not only what are the potential uses of these data today, but what might that be further on. I think there are certain dangers, though, in maybe certain modes of doing work in neuroethics. So I think a lot about Laura Specker-Sullivan and Anna Wexler's paper, which is kind of a critique of a lot of work being done where, where it's possible for an ethicist to become in some ways almost like a cheerleader for the technologies that they're raising concerns about, right? And so if we sort of fill in all the blanks in a way where we take some speculative potential neurotechnology, and then we assume that all the technical challenges are surmounted, and we assume that all the social and cultural barriers to adoption are surmounted, then it sounds like somebody's like writing a brochure for the technology, right? Like that's like saying, this is coming and everyone's going to be using it, and we're going to fix all these problems, and people won't be able to resist using this technology. It's going to be so good. Like, at what point do you start sounding like the investors' perspectives for some companies? So I think there is a little bit of that danger of, to some extent, like assuming that these technical as well as I think sociocultural barriers to adoption of neurotechnologies are going to sort of go away, and that sometimes leads to a really, really narrow vision of neuroethics that often also is centered on the kinds of concerns of communities that are already very, very enthusiastic about neuroethics, right? And so not thinking a lot about the breadth of opinion and fears that people have about neurotechnologies. So I think that is a certain kind of danger of, I think, more a certain mode of doing work in neuroethics that I think that we as a community need to be a little bit cautious about. And so in the same way that we've talked a little bit about neurohype, I think there can be a danger of sort of ethics hype. And again, I think that's less a matter of the kinds of broad principles that Sarah's talking about wanting to articulate, and more, I think there's a danger sometimes, like if we make it somebody's job to like think about all the potential problems of a technology that hasn't arrived yet, then that person has an interest in other people thinking that these technologies that haven't arrived yet are going to arrive, right? Because otherwise, this person doesn't have a job. And also, I mean, we all want to think that our work is important and meaningful. And so, I think that just thinking sometimes about like the structure of people's roles and how people understand their roles within ethics, is something where if we're not careful, we can create these conflicts of interest in terms of, what role we play in shaping people's perception, right? And so again, if my job is to prepare us for like the implications of some far off technology that might be here in 10 years or might not, then it's going to be hard for me to avoid, feeling compelled to make everyone, think a lot and worry a lot about the fact that this thing is coming in 10 years when, there's a lot of technical and other challenges that may or may not be surmounted.
Can I just say, that sounds right to me, and I think that's a really interesting paper. I do also think that there's a role for people to have, it's like having progressive vision or something, right? Bifocals, where you see the near and you have to pay attention to what's happening, but you have to keep looking out into the future. And I'm not sure why, it seems if people are only focused on that future, then we're going to run into that problem. But I think in my own work, talking with people who are current users of devices, when these issues come up, you think, okay, so we're having them now with the less capable, less useful technology that's still very experimental. Where are we headed when we think to the future? And let's, my thought is, let's make sure that these problems or concerns that are there now are fed back into the design process so that any future technology is taking those things into account. And some of those things I think are going to be about making sure that people, the individual user, stays in the loop, right? Feels agential in their use of the device, and has a sense of control. Like most of us aren't fully in control of our lives, let's face it, but we like to think that we are. So it's not, rock solid control, but to have some sense of agency over that thing, I think is really important. And I guess the other thing I would just add there, I can't remember, were you at that BBQ thing, brain and behavior quantification? It's a barbecue.
So many acronyms.
Yeah, I know.
It's
The
a blur.
NIH ran, I think it was the NIH ran this big meeting of neuroscientists and others, maybe some people in the audience were there for brain and behavior quantification, where the idea is you can be doing neural recordings at the same time that you have lots of sensors around you recording other things, even just video, right? To know exactly what you're doing, maybe a heart monitor to know how your heart rate changes in response to what you're viewing, and all these things, so that we have massive amounts of data that we can better correlate what's going on neurologically while all these other things are happening in the world. And I think my sense in that group was just everyone was so gung-ho about getting more and more and more data. If we could just get more information, we're going to have such a better vision of what we are, right, and how people interact in the world. And I just find it a little bit off-putting. I don't need to have all the data. I get that we'll understand our brains better, but I think even the individual participants, their level of privacy is just so diminished in this. Like everything that you're doing for whatever period of the study is being recorded. We all privacy is not about, as somebody said in the previous panel, having something to hide. It's about having a separate space and the capacity to negotiate the boundaries of intimacy, right? So that only certain people see me when I'm completely relaxed, and they're people I trust. I don't know. It just worries me sometimes where the push is to have more and more information provided.
I'm sorry to have to cut this off. We've run out of time for the discussion section, and we need to move on to audience Q&A. So if any in-person audience members have questions, they can move over to the microphone to ask them. And we may also have some Zoom questions.
Discussion. Oh, there we go. I was wondering, I really appreciated the discussion about how these devices can impact people's sense of agency and identity. And Winston, you were alluding to how that's already something that people with different brain conditions are dealing with, either from the condition itself or maybe from medications they're taking. So I'm wondering if there's things to learn from how we have tried to help people deal with those issues of agency and identity in dealing with a condition or in dealing with medication use, practices from ethics or philosophy or counseling practices that can then be applied in the context of these devices?
I'm worried I'm going to answer a different question because I jumped out of me. I mean, I think one thing. So one thing that I think is interesting is that right now there's a small group of people who are using these devices, but as I mentioned before, we have a tremendous amount of like popular art and movies and cultures that are focused on these kinds of possibilities, and I think that as we go further in this area, the experiences of people who have these devices, especially as they become more sophisticated, are going to affect, I think, maybe the way that we all think about our brains in a slightly different way. A few years ago, I read this book, Listening to Prozac, which is a really amazing kind of memoir of the early years of psychopharmacology. So Peter Kramer was a psychiatrist who was among the first to start using SSRIs and other medical treatments for depression. And what's really fascinating about reading this book that was written in the 80s is that there's certain things that Kramer, who's like an expert in the area, he's like at the very cutting edge of this, like he finds really, really troubling and new that just seem like so commonplace to us, that like our moods have a physical basis, and that that taking a pill every day could shift in important ways, like the way you interact with people. And there is a way in which, I mean, first, SSRIs and other medications are very, very widespread, right? So those are among the most widely used medications. But there's also a way in which all of us have taken on like a neurotransmitter or psychopharmacological view of our brain activity in ways that are sometimes, I think, a little oversimplified. But the idea that like dopamine's the reward molecule, and that you play video games because you get a lot of dopamine, or the idea that serotonin is a mood molecule, and that that you're happy. So it's interesting, like how much this enters into sort of the broad popular culture, even among people who are not users of that older technology, which is really transformed the way we think about mental illness and our own minds and moods. And so I think that I have a feeling this is really not at all a question you asked, but I hope it's interesting anyway. I think that I'll put it this way, we're very interested in research with people who are the early users of these devices, because I suspect that it's going to have something to tell us about a way in which we're all headed, regardless of whether we are future users of these devices. We're just going to be in a milieu where this sort of neurotechnological self-understanding is going to influence in subtle ways the way the rest of us think about our agency, our mood, our experience of the world.
Yeah, and I think there's so many things to say about what you ask. I think I have a relational view of us as humans without any technology in us, but I think if we're fundamentally relational beings, then there's a way in which a device that allows us to get access to some part of ourselves, as you were saying with the RNS device, right? I might learn something about my seizures through having this thing that can provide me with information I'm not able to get by myself, or I can't get from friends or family members. It just helps with self-understanding. So I think if we shift our understanding of the devices to see them as kind of helpers that build a relationship, right, that are able to do certain things for us, then we can see that a little different. I think the worry is that with friends and family members and people, right, we're separate. And so we can, when we're being bullied or controlled or whatever, we have some capacity for resistance and pushback. And I think the worry is internally, we don't have the sense of what's happening there. But as long as we have things in place that try to control for that, then I think they can just be another source of assistance.
Thank you.
Hi, this is a great talk. I have a question that is, I think, related to how devices might interact with regulatory frameworks, particularly in the US, since that's where I'm thinking about it. But I am curious whether you have any thoughts or opinions on side effects of a device, say the sense of loss of agency, and how, if you're looking at the risk-benefit analysis of a device in a regulatory context, you handle that. is there a percentage of people who can experience disruption of their sense of self that's acceptable, or is there a hard line in the sand from a either medical or philosophical perspective?
I think part of the problem is we don't have a good way to measure any of that to begin with, never mind then figuring out the appropriate percentage. But it seems to me that at least the first step is asking these questions and trying to understand what's happening. I have great admiration for the neurosurgeons and neuroscientists that we work with in our center, but these are just like before they were working with ethics people or philosophers, these were just not questions that were part of the procedure that they do in their experiments. And I think through working with us, they've realized there are some really interesting things that you learn there. So then it's setting up procedures so that even if it's not always qualitative interviews, right, there are questionnaires or other things where you're going to try to capture some of that experience. Because I think a lot of the time we're looking at the more tangible response to the device, right? Your tremor's gone, look at that. And we can measure that and we know something about it and move on. Whereas I think these agential impacts can be a little bit harder to identify and certainly quantify. Although Adina Rasky's group at Dartmouth is working on some kind of quantification measure.
Some things will depend on whether we're talking about things in a medical space or in a consumer space. In a medical space, the access to devices will be mediated by a professional relationship, which in some ways, is a barrier. We've talked before about all the many ways in which access to medical care is unequal, and so that sort of gatekeeping function is going to exacerbate certain inequalities. At the same time, hopefully that because the access to device is mediated by a professional relationship with someone who hopefully is somebody who has some understanding of where the patient is and also has some understanding and prior experience with the device, that those are situations where there's a sort of a specialized community that can develop knowledge and experience and hopefully might observe in informal ways if there are changes that we don't have a formal way to measure. Everything having to do with potential consumer access to devices is a lot more speculative, but of course the regulatory frameworks for consumer devices is itself a lot more open, right? So thinking about what's required by FDA for marketing of a medical device, and that we have really much lower thresholds for safety. In some ways, we often rely a little bit more on the litigation mechanism for protection in those domains. I think those things are going to be really kind of quite open, but I guess there will be some kind of near-term questions about what gets classified as medical or non-medical, even if it's not for a clinical indication, right? Because if something requires a neurosurgeon to put it in, then there might be good cause for FDA to say that we're assuming authority over this domain, even if it's not for treatment of a medical indication. So I think that there's a few things where at least in the US, the regulatory pathways will depend a little bit on where these things fit into the existing frameworks. And then, probably as a matter of legislation, if people have to respond to things not fitting into the existing boxes, kind of where things wind up falling.
Hello, yeah, I'm Toby from UCSF. I work with Winston and I just had lunch with Sarah. Yeah, I think what really strikes me is that in a way we're always oscillating between this techno-optimism and techno-humility, and we're trying to carve out a space where we really figure out what is in the realm of possible and what is really happening in the field. And yeah, I was just wondering if you both have maybe some advice of how to guide this discussion. I think it definitely lies in interdisciplinary discourses we're having here, and just already seeing this conversation just really helps sometimes to ground some of the expectations. And maybe even if there's a good term for it, is it like techno-moderation or just something that we can just put ourselves in to not always fall into the either side of the spectrum?
I talk to Toby all the time, so
Yeah, I don't know about techno moderation as but I mean I think I was going to say, I would just argue in favor of techno-humility generally. I mean, I try to step back from this and think, okay, so there's work going on. I do think we need to do the anticipatory work and be thinking about those things. But I also recognize we're in a, as Winston has said several times, we're in a world here especially, but globally, where so many people don't have access to basic care. And also some of the problems even within the US context. So when you said in my intro, I'm in the disability studies program, right? There are a lot of grants that I have looked at that start with how many people suffer from spinal cord injury. But the reality is there are a lot of people with spinal cord injury who don't identify themselves as suffering at all, right? And have not identified the same problems that other people identify for them. So I think being humble about those things and recognizing alternatives to improving the well-being of people that you're trying to benefit has to be a constant, you know, which is why I would say techno-humility or just humility. But I guess your question is really, then do we have to do all this anticipatory guidance if we're less optimistic about what the technology will do? And this is where I think, well, I'm going to turn to the people who are doing that neuroscientific work. And when they recognize that there are issues coming, then I think we better collaborate together to try to figure out some policies. Techno moderation.
I like techno-humility. I mean, I think that there's what's going to happen with the people who have these devices, and then there's what it's going to mean for all of the rest of us. And that's probably the part that's hardest to know. But I think if we think about, let's say two of the really, really big problems that people are looking at neuromodulation to address clinically, right? So one would be depression, one would be pain. Those are two of the biggest health problems that we have in the United States and really around the world. And there are just way too many people suffering from chronic pain and way too many people suffering from depression to imagine that we're going to get anywhere anytime soon by implanting these people with devices in their heads, right? Like we will not have that many surgeons. We will not have that many people. Like we will not be able to make enough of these things to make any kind of difference for many, many, many years, right? And it would be great to think about what that would look like many, many years from now. But part of the reason why NIH is paying for these studies in people with depression, people with chronic pain, is partly the hope that through work in these devices, we will make better headway in terms of things like, one of the huge barriers we have to pain research is that we just don't have any decent ways of measuring it. And it might be that we measure it through a brain signal, although Sarah and I could spend a lot of time talking about all kinds of problems with thinking that that's going to fix the problem. But at the very least, having a bunch of bright people thinking really, really hard about pain measurement, like they might get somewhere, whether it's with the brain signal or whether it's with something else, right? And and depression, we suffer from some similar problems in terms of telling how much suffering people are in, or whether or not, as in the great example Sarah gave, whether or not someone feeling grief is appropriate or not. That's an interpretive problem, right? So someone could feel just as bad. I mean, I guess even if we had some way of measuring that, but that's very different if they're at a funeral than if they are crying for no reason, at least no reason observable to them. So to some extent, I think one of the hopes of the amount of research and the huge investment that's being done in this area is not because we're going to make headway anytime soon on the millions of Americans and millions of people around the world who suffer from these problems by sticking things in their heads, but instead because this is the best path forward that we see for getting any purchase on these problems that have kind of bedeviled us for a long time. So I think that one reason for that sounds a little bit more like a call for desperation than for enthusiasm, but honestly, I think that's a big part of why there's so much focus on these areas, and it's less we're going to make this gizmo that's going to fix everybody, but it's more like we need new pathways for figuring this out, and we are not getting anywhere near enough to the problems with the methods that we have. And so, this is something that we are pinning our hopes on, because we recognize that there's a big problem that we're not addressing.
We have time for one more question.
All right. So moving away from devices in a way that could affect people on a mass scale, I wanted to know your take, both of you, on the specific issue of oxytocin. As an example, it's been shown to make people display some behaviors compatible with empathy. It's an empathy-like behavior. And there's these pipe dreams of people saying, oh, we could do social engineering with this, or even more narrowly saying this could be used in the criminal system or the education system. I wanted to know your take on this.
I think it's so much more I know that there are huge global problems that we have of cooperation, but I get really frustrated with the philosophers, especially who write these pieces defending, let's put oxytocin in the water so that everyone will love each other more. I just think it's so much more complicated than that. And there are all these issues around consent and whether or not it's really doing the thing that you hope that it's doing. Like, I think there are worries there about the oversimplification. That said, I think we need to be, paying attention to our global problems and figuring out ways that we cooperate. But I guess I haven't yet seen the piece that convinces me.
What do you think of moral neuroenhancement?
Yeah, I don't think that this is the way that we improve ourselves morally.
We have one more minute if you want to respond. With
A minute.
Yeah, you can do it in a minute. Come on.
I mean, I guess I count as a sort of skeptic about neuroenhancement generally. And, part of the issue is that, we don't really know a whole lot about why the brain does what it does or how the brain solves the problems that it does. And so, we do have a tendency to kind of, like, there's often this rhetorical move of like, our primitive hunter-gatherer ancestors, and we have this like obsolete piece of technology that we're carrying around. But I think on one hand, like, any world that we're creating has to be a world for like humans and human brains. So like that's sort of like it's a little hard, like, when you start pulling that out of the equation. And then I think I think that would suggest that we are in a better position, like in a better epistemic position, to figure out like what are the qualities that people need for the kinds of societies that we're building, than this, dumb evolutionary process that produced our hunter-gatherer ancestors. And that just seems unwarranted, because there's just many things that we don't know about, about social cooperation, about kind of how our brains solve the problems that our brains solve, to think that, we could do better than this 3-pound sludgy thing, right?
Okay, that's all we have time for, unfortunately. I'm really sorry to cut that off, but please join me in thanking our panelists, Winston Chong and Sarah Garing. And remember, we can continue this conversation on Slack. I can see that Francis Shen, who wasn't able to make it, has been posting comments on the Slack channel for Neuroethics. Unfortunately, we don't have time to read them out loud, but I encourage everyone to engage in that way. And join us in 10 minutes. We'll have our last session, the keynote, at 5 p.m. Thank you.